Okay, here we go. So yesterday, I presented you with this problem. The lengths of the two legs of an isosceles triangle are 4 times the length of the base. Write a formula for the area of the triangle as a function of its base. Okay. And I said, we've got to think about the area formula for a triangle, and then be thinking about what you might need to use to find the things you need to find the area. So let's start writing some of this stuff down. The area formula for a triangle is what? Base times height divided by 2. I prefer the 1/2 base times height, but it's the same thing. You're right. Okay, so we're going to be using that. And then I said, okay, think about what of that we have in the mix here and what we don't. I want this to be a function of its base, right? So that means when we're done, we should have an equation only involving b, not h, correct? So we need to make a substitution for h somehow, okay? So there's going to be some geometry in the figure that's going to be helping us with that. So if we draw our isosceles triangle here, so here's our base, and I said that the other two sides are 4 times as long. So what should I have here and here then? Or 4b, right? 4b. Now, it would be super nice if 4b was the height, because then we could just plug in 4b, right? H equals 4b, substitute it in, figure it out, we're good. But it's not. The height is perpendicular to the base right down the middle of this thing. There's h. So, I can't use 4b directly. However, I can, like we mentioned yesterday, use the Pythagorean theorem to help me come up with something I can use for h. Okay? So, let's consider for a moment just this right triangle right there. It doesn't matter which one you choose, because either one's going to have h as part of the triangle. Okay? But if I'm going to do a Pythagorean theorem just in here, okay, what am I going to have? What squared plus what squared equals what squared? How would that look for that particular triangle? Yeah.
Half b squared plus h squared equals 4b squared.
Mm-hmm. So half of b squared, that would be from the bottom, right? Plus h squared equals 4b squared. Okay. And what am I going to have to do with this now? This Pythagorean theorem equation that I've pulled out of this thing. Well, ultimately, what's the goal, though? Solve for h, right. And beginning that process, we're going to want to square some things out and move some things around and all of that. So let's start doing that, okay? Got to solve it for h. So 1/2 b squared. You're going to square the half and square the b. So it's a quarter b squared. H squared is still h squared. 4 squared and b squared on the next part here. So that's 16 b squared. Okay, and then you're going to do a subtraction, right? We've got to move the quarter b squared to the other side. And those are like terms, right? They're both b squareds. So we got to do 16 minus a quarter. Okay, and I don't care if you want to slip into decimals here because it's a little easier. So it'd be 15.75, right? Once you subtract. Subtracting a quarter from 16, so yeah, 15.75 b squared is fine. And then what? Square root it. Now we've talked about if you square root both sides of an equation, technically you need to have the plus or the minus, right? However, in this case we don't. Anybody know why? Yeah.
Because it's a length of a triangle and you can't have
Exactly, right. The negative part of that answer doesn't make sense in the context of the problem. We're talking lengths of sides of a triangle. You can't have anything negative that's a length, so we just take the positive for this one, okay? So that kind of works out nice for us. But in any event, it's the square root of 15.75 b squared. So pull out my handy-dandy calculator. So the square root, where's the square root in this? Ah, there we go. Square root of 15.75 is about 3.97, somewhere thereabouts. And then the square root of b squared is just b. So that's going to be the substitution I want to use. Okay? So if I go back to my area formula over here then. So the area is 1/2 b multiplied by this 3.97b. And that can be simplified a little bit, right? Multiply the 1/2 with the 3.97. So divide that by 2, get about 1.98. And then we're going to have a b squared. So our a of b is 1.98 b squared. That would be the final formula. Okay, so sometimes we might have to employ the Pythagorean theorem to help us out, especially when you're talking area of triangles like this. Because the area of a triangle is reliant on that height, and so you have to figure out a way to get at that height in terms of whatever the variable is you need. In this case, it's the base b, and then you can do your substitution back in. Okay, but in general, it's the same kind of idea. We just got to go through that first. Okay. Okay. The geometry, making formulas kind of thing, and transition here just a little bit. I'm only going to do one example of this next thing because it's pretty straightforward, and you've done a lot of it in the past. And there's going to be some problems in your assignment involving percents, and I just wanted to briefly talk about that. So if you're going to talk about something that increases or decreases by a certain percent, okay? So that's some amount that's going to increase by X percent. So it could be, 32%, 56%, whatever it is. We're just going to call it X for now. Okay? What do you do to the amount you have right now if you know that it's going to increase by a certain percentage? What do you actually multiply it by? Exactly. It's always 1 plus whatever that percentage is. Okay? So to do that, you're going to take the amount and then multiply it by 1 plus the X percent. If you're going to decrease by a certain percentage, how does that process change then? It becomes just a minus, right? Yeah. Yep. So it's whatever your current amount is multiplied by 1 minus X percent. So we're going to use this idea to just work through story problems, that sort of thing. And like I said, I'm just going to do one with you. You'll have a couple on your assignment to take a look at. So let's say we've got a population has grown by 35% over the past 5 years and is now 2 million people. So what was the population 5 years ago? Okay, so is this an increase or decrease problem? It's an increase, okay? Now, does that mean you take 2 million and multiply it by 1 plus 35%? No. Take a look at how I set it up. It says it has grown by 35% and is now 2 million people, right? So this little equation up here that we talked about is going to be equal to 2 million. That's the final result of the growth, right? So we're going to have some amount times, and take the percent and turn it into a decimal as well. So 1.35, so something times 1.35 has gotten us to 2 million. Okay, and instead of, if you don't want to use the little AMT for amount, I mean, you could turn that into just X or whatever. I think I'm going to just make P instead of AMT. So population times 1.35 got us to 2 million. Okay, so once you got it set up, then it's pretty simple, right? Just solve that equation. Divide, done. Okay, so what was that old population then before the growth? $436,000. That seems awful small. That sounds better. Say that one again. 1 million what? Anybody else get that one? Yeah, okay. That sounds a little more reasonable. Maybe you missed a... You probably did 200,000 instead of 2 million. That would be my guess. So 2 million divided by 1.35. Yeah, it's the 1481481. Yep. Nope. Because of the fact that I said over the past 5 years it's grown this much. So what was it 5 years ago? It's the same time interval, so it doesn't matter. I know over that 5 years it's been that 35%, so it's not going to change. Now, if I had asked what was the population 1 year ago, that would get a little bit more sticky, but we're not. Exactly, that it's growing by the same amount each year, turning it into an exponential problem, and then solve that. But we're not doing that with this stuff. It's just a straightforward percentage of growth. So, yeah, don't want to make it more difficult than I need to. So, that would be it. Okay. So, just wanted to make sure we're still okay with how percents work that way. We have to add it to 1 or subtract it from 1 and use that to help solve the problem. Okay, I'm going to stop, let you guys get going on some work here.